Our planet's existence depends on the sun, a colossal engine that shapes our seasons and sustains life. Though it seems constant, the sun has its own cycles, including periods of rest called solar minimums. During a solar minimum, the sun's activity drops. Sunspots vanish, solar flares become rare, and its magnetic field weakens. This isn't a crisis, but a natural phase in the sun's life. Even from 93 million miles away, these subtle changes ripple through Earth's climate. In the UK, where weather is a tug-of-war between oceanic and continental air, the sun's quiet phase can tip the balance. The solar minimum's gentle dimming can nudge weather patterns, sometimes making winters colder and more memorable. Understanding this cycle isn't just astronomy, it's a vital clue in the story of our climate. The sun's slumber, though distant, leaves its mark on our winters. It's a reminder that our world is deeply connected to its star. The sun follows an 11-year cycle, swinging from quiet solar minimum to stormy solar maximum, and back again. This rhythm is driven by the sun's magnetic field, which twists and tangles, creating sunspots and powerful eruptions at its peak. At maximum, the sun bristles with sunspots and flares. At minimum, it calms and its magnetic field weakens. Remarkably, every cycle ends with the sun's magnetic poles flipping. A full magnetic cycle takes 22 years. This cosmic heartbeat shapes the space around us and subtly influences Earth's climate. The sun's cycle is a powerful reminder that the universe is always in motion. Its pulse sets the tempo for life on Earth. And it's this very cycle that helps shape our winters. During solar minimum, the sun's face often appears spotless. Sunspots, those dark marks of magnetic turmoil, nearly vanish. With fewer sunspots, violent solar flares and coronal mass ejections become rare, making space weather calmer for satellites and astronauts. The sun's total energy output dims slightly, just 0.1%. But even this tiny change can influence Earth's climate. The solar wind, a stream of charged particles, becomes more stable and predictable. The sun's weakened magnetic field lets more cosmic rays reach Earth, another subtle shift during this quiet phase. These changes may seem minor, but they ripple through our planet's atmosphere. The sun's calm is more than cosmetic. It's a shift in the energy that reaches us. Even a quiet sun can have a profound effect on our world. The solar minimum is a time of subtle but important change. It's a reminder that even silence from our star has consequences. How does a quiet sun affect UK winters? The answer starts high in the stratosphere. During solar minimum, less ultraviolet radiation cools the stratosphere, especially in the tropics. This cooling weakens the polar vortex, a high-altitude wind that usually traps Arctic air. When the vortex falters, frigid air can spill south, reaching Europe and the UK. This chain reaction, called sudden stratospheric warming, opens the door to severe cold snaps. Instead of mild Atlantic air, the UK gets icy winds from Siberia and Eurasia. A quiet sun sets the stage for these dramatic shifts. It's a striking example of how distant solar changes can freeze our winters. The jet stream, a fast river of air high above, holds the key to UK winter weather. When it flows straight and strong, mild Atlantic air prevails. But during solar minimum, the weakened polar vortex makes the jet stream wavier and more prone to blocking patterns. These blocking highs can linger, diverting the usual flow and letting cold, dry air from the east sweep in. This is the classic Beast from the East setup. The jet stream's wobbly dance opens the door to Arctic air. The sun's quiet phase increases the odds of these blocks. The result? Prolonged cold spells and snowy winters. The jet stream's path, shaped by the sun, decides our winter fate. Even a subtle solar nudge can tip the balance. The most dramatic link between a quiet sun and cold winters comes from history's Little Ice Age. Between 1645 and 1715, the Maunder Minimum saw sunspots nearly vanish for 70 years. Europe endured brutal winters, frozen rivers, failed crops, and widespread hardship. While volcanic eruptions also played a role, the timing with the sun's slumber is striking. The Maunder Minimum is a powerful case study. When the sun's activity plummets, northern Europe freezes. It's a chilling reminder of our star's influence. Even today, scientists look to this period to understand the sun-climate connection. The echoes of that frozen era still shape our understanding. We don't have to look far back to see the sun's quiet influence. The winters of 2009 to 2010 and 2010 to 2011 were the coldest in decades, with heavy snow and prolonged freezes. These years coincided with a deep, extended solar minimum, one of the quietest in a century. The polar vortex weakened, the jet stream blocked, and Arctic air poured over the UK. While other factors matter, the timing is hard to ignore. A quiet sun doesn't guarantee a cold winter, but it stacks the odds. Recent cold snaps are vivid reminders of this connection. The sun's slumber can still chill our modern world. Scientists are detectives, piecing together the sun's influence on our winters. They study centuries of sunspot records, weather diaries, and even ice cores that trap ancient air and cosmic ray markers. By comparing solar activity with climate data, they uncover patterns stretching back thousands of years. Sophisticated computer models simulate how solar changes ripple through the atmosphere, testing theories about the polar vortex and jet stream. Satellites now monitor the sun and Earth in real time, tracking every flare and weather shift. This blend of history, technology, and modeling brings us closer to understanding the sun's role. Each new solar cycle is a fresh experiment. The detective work continues, revealing the sun's hidden fingerprints on our winters. The sun's cycles are a subtle but significant force shaping our climate. Evidence from history, ice, and satellites shows that solar minimums can load the dice for cold UK winters. The mechanism, less UV, cools the stratosphere, weakens the polar vortex, and lets the jet stream wobble, opening the door to Arctic air. The cold winters of 2009 to 2010 echo the grand freezes of the Maunder Minimum. Yet, the climate is complex. Ocean cycles, volcanoes, and global warming all play a part. Scientists are still unraveling how these forces interact in a warming world. Each solar cycle brings new clues, deepening our understanding. The story of the sun's slumber and our winters is still unfolding, reminding us how deeply we're connected to our star.